stage is set. The fighting ensues. No matter what war, no matter what battle, no matter what era, this will be the climax of the drama. But this is Act 3 of the play. In order to wage and sustain any war, much work has to be done. Any battle actually begins long before the soldiers engage, when planners determined that it was possible to arrive at the battlefield. With aircraft, land vehicles, and ships, planners supply soldiers with weapons, ammunition, food, and medicine. And they maintain that supply using military movers, transportation designed specifically to move military cargo.
The infantry fights for what they call key terrain, but to understand these battles and where they occur, you have to understand how people get to the battlefield.
Military movers can range from giant aircraft carriers, sometimes used to transport troops, to heavy-duty helicopters that lift supplies into the war zone. They have included trucks, barges, flat cars, boats, even jeeps and Humvees. This is the top of the line for today's military movers. A 174-foot-long, 270,000-pound C-17 cargo plane, capable of traveling at over 500 miles an hour for over 3,200 miles on a single fueling. With four 42,000-pound turbofan engines, it is capable of 162,000 pounds of thrust.
The C-17 has been a marvelous airplane. Its reliability is great. It allows us to move 18 pallets or any number of passengers into country to go into very short runways for takeoff and landings. And when we surgically went into Afghanistan and took out the runway, we then had to come and operate out of those same runways.
The hold on this megaplane is capable of transporting jeeps, Humvees, even tanks. It can also be reconfigured to accommodate 102 paratroops, or 144 regular troops, or 48 litters for medical evacuations.
The purpose of this plane is basically anything the Air Force wants it to do. They'll get things to the front line as soon as possible.
The C-17 has some spectacular features that make it a favorite of logistics planners. One is its ability to refuel in midair.
We have a regular C-17 which holds 180,000 pounds. We have an extended range which I believe holds 220,000 pounds of fuel and gets us pretty far. And they have an aerial refueling receptacle on the top of the airplane, and we can stay in the air as long as they need us to.
One other thing that makes this plane a little bit unique is we can fly with night vision goggles, and so we can go into dimly lit or runways without any light. It also helps us to scan for threats in a combat environment. It's actually one of the easier planes to fly because it is all glass and it does a lot for you. We have autopilot and auto throttle, so you can hook those up and it'll do everything for you. It's really a lot of fun to fly.
The turbofan engines are a hybrid of old piston-driven propellers and jets. The C-17 is the culmination of nearly a century of military aviation research and development. And it is the most recent of the many C-designated or cargo aircraft military movers in the Air Force arsenal. Before the 20th century, transportation consisted of land or sea travel. But within that century, air travel blossomed into one of the most effective and efficient logistical tools. Cargo aircraft really began with the more sophisticated twin-engine propeller planes developed in the late 1930s, specifically the C-47 and C-46.
It's interesting to look at the quantum leap and evolution that takes place between World War I and World War II, where you jump up to a level of technology where you have multi-engine, piston-driven aircraft capable of carrying 6,000 pounds of cargo in the case of the C-47, 10,000 pounds of cargo in the case of the C-46.
The C-46 Commando was capable of carrying as many as 50 men and had 2 loading doors. The more familiar C-47 carried only 28 men and had 1 door, but served in a combat role towing gliders fires and dropping paratroopers into enemy territory. The post-war period saw a series of piston-driven airplanes like the C-119 boxcar, supplanted by the turboprop workhorse C-130 Hercules, and ultimately, the jet-powered C-141 Starlifter. The biggest of them all was the massive C-5. At the time of its introduction in the late 1960s, the largest aircraft in the world. But a military mover 247 feet long and 65 feet high, with a 270,000-pound payload and a maximum takeoff weight of 840,000 pounds, needs its space and about 8,000 feet of runway. And this is where the C-17 comes in. The smaller, more agile C-17 would do what the lumbering C-5 could never do, and in places the C-5 could never go. The C-17 was conceived in 1980, when the Air Force requested a versatile cargo plane with a large load capacity, combined with the ability to land at unimproved airstrips under battle conditions.
The C-17 is obviously smaller than the C-5 Galaxy. The C-17's overall size is closer to, say, a C-130 or C-141, but at the same time, it can carry more than a C-130 or a C-141. So by having smaller aircraft that costs less money overall to manufacture, we can have a larger fleet of C-17s.
One of the C-17's most important features is that it is a big, empty shell. Loadmaster Scott Wetzel is in charge of filling this one.
The Loadmaster is a jack of all trades. For cargo missions, the Loadmaster plans the cargo, where it's going to be placed in the aircraft. We determine how much the aircraft weighs. We have to balance the aircraft for flight. When we carry passengers, the Loadmaster administers meals. We pass out blankets, pillows, comfort items for the passengers.
Loading this 18-foot wide, 15-foot high compartment with 172,000 pounds of freight requires a computer, a crew, and a plan.
Right now, the aircraft is set up to download the rolling stock. Once the rolling stock is off the aircraft, we would need to reconfigure the floor to move the pallets out. To do that, first thing we're going to do is flip over all the rollers. We raise the guide rails. The aircraft would be open. We come over here to the side panel. These pallets are locked into the side rails. The locks are electrically controlled. They're going to retract into the floor, and that will release the pallet. Then all we would do is simply push the pallet off the aircraft.
Specially designed hydraulic forklift cranes called K-loaders help load the C-17 and can even be driven right on board through the back loading ramp.
It reaches up to 225 inches up in the air. It can uphold 25,000 pounds of cargo or rolling stock at one time.
The C-17 began assisting military operations in the Balkans in the early 90s, having just missed action during the Gulf War. Since then, it has proven itself in hundreds of humanitarian sorties, dropping 2.5 million individual rations during Operation Enduring Freedom in Afghanistan and Operation Iraqi Freedom.
I believe it's the cream of the crop. I fly on them as well, and they've done things that I've never seen any other airplane do before. It's got great maneuverability, short distant landing, takeoff. It can haul anything. It's great airplane.
A specially constructed flight simulator helps pilots get a feel for the C-17. But much of the actual flying is done with onboard computers.
This is what we use to control the aircraft for turning and climbing. These are our throttles, and this gives us the power. We have our flaps right here. Down in here, this is our computer. Pull up a flight plan, and you put where you're going to fly to in the computer, and then it'll come up on here. So you can hook it up to the autopilot, and it'll fly it for you.
Not surprisingly, in addition to the 120 aircraft which will be fully delivered by 2004, the military has requested another 60 C-17s. And until the next generation of aircraft flies from the drawing board into the war zone, the C-17 Globemaster III will remain the most flexible of all the airborne military movers. In June of 1944, a Louisiana shipbuilder helped break the back of the Axis powers when the Allies gained a logistical stronghold in occupied France. Andrew Jackson Higgins built the boats that brought victory to Europe in World War II.
Eisenhower told historian Stephen Ambrose that Andrew Higgins was the man who won the war for us, which is an incredible statement. Now, Adolf Hitler also called Higgins the new Noah because of the boats that Higgins designed and developed.
Hitler and his generals had spent years fortifying the occupied European coastline with obstacles that included coast artillery emplacements in what became known as the Atlantic Wall. Deepwater ports like Cherbourg and Le Havre or nearby Calais were the most likely invasion points and thus most heavily fortified, which is why the Allies didn't invade there. Instead, they knew that Andrew Higgins had designed a boat that made those ports unnecessary. All of Higgins' many boat designs had shallow drafts to float over hidden mines and a nearly flat bottom that enabled them to sail right onto the beach. Certain boats had a ramp-like door in the front that allowed fast unloading of troops, jeeps, tanks, even small bulldozers.
Thanks to Higgins, whenever the Allies went to invade, they no longer had to sweep a harbor of mines. They no longer had to take an enemy-held port in order to land their assault troops.
The Higgins vote was of absolute crucial importance to the war-winning effort in World War II, mainly because of the fact that it gave the Allies an ability to transition troops and big ships in deep water across an open beach and to allow them to go into combat. This was an ability that prior to that was largely unheard of.
Higgins was an enterprising Louisiana timber importer who realized he could make more money converting his timber into boats, which he sold retail, than he could selling wood.
And he started making boats for the trappers and the oil field companies to allow them to go into the bayous, into the shallow waters that could navigate over sandbars, that could pull up on the side of a bank and retract without damaging the bow or the propeller.
When Higgins saw that the Navy was trying, without much luck, to develop a military landing craft throughout the 1930s, he thought he could sell them his Higgins boat design. At first, they weren't interested.
He was an Irishman who said he didn't wait for opportunity to knock. He'd kick the door down and drag the old harlot in. He told them that his boat was better. He told them in explicit words why their boats were inadequate. And he didn't mind telling the admirals face to face what he thought of it. The Navy disliked this. They saw him as the small, arrogant boat builder from the South. The Marine Corps saw him as a savior.
The Marines, the only service practicing landing operations in the late 1930s, realized that the Higgins boats did what Higgins said they could do. And since the Marines were the ones that were going to be landing in them, they forced the Navy to test them. Sure enough, the boats could ride right up onto the beach without doing any damage. The skag underneath the boat was built out like a housing, protecting the propeller and digging a channel in the sand when the boat rammed the beach. This also made retraction easier. Of special interest to the military was a feature adapted from a Japanese landing barge, the drop ramp front.
You could load 36 armed men standing in the upright position with packs on their backs and rifles in their hands, run that thing up onto the beach, drop the ramp, and in a matter of seconds, literally a matter of seconds, they could run off of that landing craft in the upright position and deploy into combat. It was recognized soon thereafter that having that ability was very useful to use in a tactical situation where a landing was being conducted under opposed circumstances, and in other words, landing troops under fire.
Higgins designed what became the Navy's LCP, or Landing Craft Personnel, for landing soldiers, LCVP, or Landing Craft Vehicle Personnel, for landing soldiers and equipment, such as jeeps and small bulldozers, and LCM, or Landing Craft Mechanized, for unloading armored vehicles. In fact, Higgins designed more than 60 different landing craft. American mass production ensured there would be enough of them to overwhelm the enemy.
The United States was able to produce and equip practically all of our allies with landing craft throughout the war. Higgins Industries in New Orleans alone made 20,000 landing craft.
This was quite an order for a small boat builder, because the boats were built almost entirely out of wood, except for the metal ramp. Metal would have been too expensive and complicated to use. Higgins managed to acquire the last 3 shiploads of Philippine mahogany before the Japanese invaded the islands. Mahogany was used because it was a very strong hardwood. With the orders stacking up, Higgins created a larger factory. Meanwhile, he began assembling boats in the streets of New Orleans until the facilities were ready. With all the work that Higgins needed to accomplish for the war effort, he was able to employ a huge percentage of New Orleans' working population.
Having 20,000 people, he knew he needed every able-bodied person he could get, and race didn't matter to him. He hired people out of beauty parlors, he hired people who were chauffeurs, which didn't really sit well probably with the local community businesses. He was paying higher wages because he needed the people, and the employees loved Higgins. He wasn't just an industrialist figurehead. He knew the business from the wharf up, and they respected that in him.
So would the soldiers who took the Higgins boats into Normandy.
They used to call the ramp the gates to hell, because that was their only protection. Coming in, that metal ramp stopped the bullets.
And so for the men that were standing on the other side of that ramp, it had to have been absolutely horrifying to know that as soon as the ramp dropped, there would be nothing to stop those bullets entering the crew compartment.
The boats were designed for logistical support, not for enemy gunfire. The ramps on the LCVP were necessary to unload equipment, but when they dropped, soldiers on the boats were exposed. One of the most famous landings made by the Higgins boats was at Normandy, where they delivered men into some of the fiercest fighting of the entire war. Because of a rising tide and other conditions at Omaha Beach, coxswains were often unable to deliver soldiers onto the sand, instead unloading them into surf. Some men on these boats leapt overboard, only to encounter deeper water. Weighed down by their gear, many were drowned. But the vast majority of boats traveled close enough to the shore to unload. And once there, they made it impossible for the Allies to be dislodged.
We effect our landings on June 6th, and what continues for 3 months thereafter is providing sustaining logistical support to those armies fighting in Normandy. We had not captured Cherbourg, we had not captured Le Havre. In other words, we did not have a deep water port. And the only way that we kept a force of 250,000 supplied fighting in Normandy, the way that we kept the ammunition and the fresh water and the fuel and the extra socks supplied to our armies was by delivering them over the open beaches that had been captured on June 6th.
Though justly famous for their performance at Normandy, the Higgins landing craft proved valuable throughout the war, including over 115 landing operations in the Pacific Theater, also known as D-Day landings. They even proved useful after the war ended, long after Andrew Jackson Higgins died in 1952.
The same design was used in Korea. The same design initially was used in Vietnam. Now, if you think of what happened to the aircrafts, you went from the B-17s to the B-52s, but the little boat that carried the men and equipment stayed the same. It was such perfect design for what it was needed for that they really didn't have to change the design of that boat until they got to the hovercraft now, the modern crafts, the L-cats.
Today, nearly all of the original World War II Higgins boats have rotted away. At the National D-Day Museum in New Orleans, George Benedetto has built a Higgins boat LCVP to the exact specifications of the original blueprints.
We were able to find a few of the Higgins people who were still alive at that time that we got a fair amount of knowledge from. We have a fairly good set of plans, and there are some books out there. The framework of the boat probably has 4 times the normal skeleton internal frame structure that most typical boats have. When the boat is sitting at rest and not underway, simply the bottom cut for the door is above the waterline. Actually, there's an incredible sealing system on it. It winches in tight to the hull, so even the water coming up is stopped from coming in.
The Allies got their money's worth from Higgins and his landing craft. His boats proved to be tactically and logistically irreplaceable during one of the most important invasions in human history. From their decks along the Normandy beaches, the Allies were able to launch a drive straight to Berlin and ultimately victory. Welcome to LCAC country, where there's no beach out of reach, according to the United States Navy. Maintenance and training on the Navy's LCAC, or Landing Craft Air Cushion, takes place here at Camp Pendleton, outside of San Diego, California. In some ways, the LCAC is a descendant of the Higgins boat.
The LCAC is recognized as being the next step in the evolution of landing craft technology. Of course, during World War II, landing craft technology developed to the point where you have independently powered boats capable of running up onto the land, dropping a ramp to unload.
Then again, it's nothing like the Higgins boat at all.
LCAC technology is a different approach altogether. It's almost like comparing piston-driven aircraft with jet-powered aircraft. A boat that actually floats on a cushion of air on the surface of the water that's capable of transitioning from a water environment across an open beach and continuing on inland.
Floating over water, land, ice, or snow, the LCAC can operate at temperatures as high as 120 degrees or as low as 30 degrees below 0 Fahrenheit. But floating isn't as easy as it might seem. Balancing the craft can be a challenge.
Being a hovercraft, we're actually riding on a cushion of air that's held in by the black rubber skirts you see around each craft. So we're literally riding on a cushion of air, just like an air hockey puck. I've heard it described best as probably trying to balance on the edge of a razor blade. In actual operation, you're using both feet and both hands to keep the craft under control at all times.
These $22 million military movers can carry more than 60 tons in payload, traveling at speeds approaching 50 miles an hour for more than 200 miles in a single 7,130-gallon tank.
As far as operating, it takes a lot of controls, a lot of multiple tasking. You got different comms in both ears, and the navigator and the craft master are working in conjunction. It's pretty intense.
4 TF-40B gas turbines provide 3,955 horsepower to the 81-foot-long, 19.5-foot-tall craft. 2 12-foot pitch propellers move it forward and help keep it upright. But it takes more than that to lift an LCAC up into the air.
We have 4 what we call lift fans that when the engines are running, they suck outside air in and force that air underneath the craft. That causes the craft to rise approximately 5 feet.
They put out 1 million cubic inches of air per second. Half of the air is transferred to the bow thrusters, the other half is produced to the bag, which gives us our lift. The bow thrusters give us bow direction. If the bow thrusters point left, of course the boat's going to turn right. You point them right, the boat's going to turn left.
A crew of 5 staffs a typical LCAC. Navigating a giant air hockey puck takes a lot of practice and skill.
It's very complex. It is multi-dimensional, so you've got to be on the ball when you're navigating.
Flat surfaces are best for the LCAC's hovering ability. It has trouble over rough terrain such as hills or brush over a foot high. If for any reason it goes off cushion or loses its hovering ability, it has buoyancy boxes that prevent it from sinking. Naturally, all that wind kicks up plenty of salt air and sand. LCACs have to be detailed after every mission to reduce the inevitable corrosion. Despite their precarious-seeming locomotion, LCACs are built tough, and they've proven themselves valuable military movers.
The LCACs were designed with Marine Corps equipment in mind, of course, and so we can carry everything from Humvees all the way up to an M1A1 Abrams tank.
LCACs were deployed during Operation Enduring Freedom and Operation Iraqi Freedom, helping bring men and supplies from ship to shore at military outposts.
I was out there and we made our mission, you know, and did our job. First ones out there, took all the troops to the beach. You know, I felt like I was serving my country and did my job, you know.
The Navy maintains a fleet of almost 100 LCACs in the U.S. alone. With a lifespan of approximately 20 years, it has become an invaluable Navy military mover. The railroad brought revolutionary change to warfare. It was the first modern logistical tool ever used by any military. It greatly increased the speed with which armies could organize for battle. Before the railroads, there was human power and animal power.
When you think in terms of 19th century warfare, you're thinking in terms of a campaign or battle that moves at about a 4-mile-an-hour pace. Okay, as fast as a walking man, as fast as 4 mules pulling a wagon. But when you introduce the railroad into it, all of a sudden, the speed at which men and material moves across the battlefield increases.
Machinery took over the supply routes. Locomotives carried men and materiel faster than ever before. And soldiers arrived rested and ready to fight, with even more men ready to be shipped out at a moment's notice.
If you want to look at what the technological advancement was, it's the steam engine. And for land transportation, yes, the railroad is probably the greatest technological innovation in transportation up until the internal combustion engine.
The earliest steam locomotives of the 1830s were delicate contraptions of no more than 3 to 6 tons that moved at a modest 10 to 15 miles per hour. But 30 years later, the iron horse had matured into a roughly 30-ton behemoth, capable of pulling loaded cars at speeds of 25 miles per hour.
In terms of military equipment being used in theater and transported by locomotive, I'd say that the American Civil War was the point where it all started.
In April of 1861, Fort Sumter fell to the Confederates, ushering in the Civil War. In May, Northern forces were sent to confront the Southern Army in Virginia, which they did at Manassas, 25 miles from Washington, D.C.
Manassas Junction is a railroad junction. You got to get control of the railroad because you have to sustain your forces. You can haul more cargo by rail than you can by wagon.
Here at Manassas Junction, the Orange and Alexandria Railroad joined the Manassas Gap Line, which crossed the Blue Ridge Mountains. The Orange and Alexandria also connected with the Virginia Central into Richmond, capital of the Confederacy. Northern control of this junction would allow Union soldiers to take the rail straight into the heart of the Confederacy. The South acted swiftly in what would be the first major battle of the war. On the eve of the attack, which commenced on July 21, 1861, the Confederates quickly moved 11,000 soldiers by rail, 65 miles from the Shenandoah Valley to Manassas, to reinforce the soldiers already there. In the end, the South was victorious.
At the Battle of Manassas, the South, they move more people into the battle area in the days immediately preceding the battle than the North does. But that's a rare example. That doesn't happen in terms of benefiting the South again during the war.
From Manassas forward, the railroads would be invaluable military movers of men and materiel in the prosecution of the war.
Everybody did learn real fast. From that point on, the railroad junctions become the most critical objectives of the war.
Rational people could have forecast the outcome based on railroad density alone. And just by recognizing the incredible value of railroad lines, you could have forecast the outcome of the conflict right then and there, recognizing that the industrial power of the North was far superior than that of the South.
Not only could the North more readily produce locomotives, it began the war with over 2/3 more track, 22,000 miles worth, compared to the South's 9,000. Further, the Industrial Revolution impacted the North far greater than the agrarian South. Mining and refining centers were also located in places like New England, New Jersey, and Pennsylvania. Consequently, so were most of the iron workers. In fact, 96% of all the state's locomotives were manufactured in the North at the time of the Civil War. The Confederacy also built railways during the war, but they often ended up in Northern control, as Union forces pushed further into the South, occasionally hastening a Confederate defeat. When Union forces landed on the peninsula near Fort Morgan, Alabama, they made use of a Confederate spur line, which was 4 miles from the fort.
The Union forces during the siege of Fort Morgan would move artillery pieces, they would move artillery ammunition, they would move people, they would move food, everything that was necessary to sustain the Union forces besieging Fort Morgan moved back and forth on this Confederate rail line. They ultimately forced Fort Morgan's capitulation.
As Fort Morgan proved, the rails didn't choose sides. Whoever had control of the tracks could use them to their advantage. Without adequate railroads of their own, the South busied itself trying to destroy lines under Northern control.
You see, especially toward the latter part of the war in the Tennessee, Northern Alabama area, there are Confederate raiders that will move behind Union lines and busy themselves cutting telegraph lines in addition to focusing in on destroying railroad networks. Confederates recognized that that was a very valuable military target, one worthy of going after with raids.
Despite these disruptions, the North was an unstoppable force from 1863 on, as it methodically destroyed Confederate logistics.
The key to it is to sever the South's ability to resupply itself or to shift food that is grown in the West to the East, or men and material. Right? And that is why Atlanta becomes so critical, is because all these railroads join there. And if you can reach Atlanta and sever it, then essentially you have divided the South.
The South conceded defeat in 1865, 8 months after the fall of its railroad hub in Atlanta. After the Civil War, the internal combustion engine would influence and eventually dominate mechanized land transportation. But the very first mass military mover continued to provide a vital logistical purpose throughout the First and Second World Wars, transporting troops and cargo, especially throughout Europe. All modern military movers ultimately take their orders from a single command, whose only responsibility is military transportation and logistics. At Scott Air Force Base in Illinois resides the United States Transportation Command, home of U.S. military logistics.
It was a Civil War general who once said, "Victory goes to the side that gets there first with the most." And we're quite proud of U.S. Transportation Command and our components for all that they do, because, in fact, if that's the litmus, the United States will win.
United States Transportation Command, or U.S. Transcom, coordinates land, sea, and air transportation for the Department of Defense in times of war and peace. The command consists of 3 military transportation components: the Air Force's Air Mobility Command, the Navy's Military Sealift Command, and the Army's Military Traffic Management Command. On the eve of any war, military experts have always considered 3 important aspects. One is battlefield tactics. Another is war strategy. The third is logistics, and it concerns arriving with troops and supply lines and sustaining them for the duration using military movers. Logistics has always been the umbilical cord for any military action.
It's providing the movement into a theater so that we can prosecute a war, so that we can provide sustainment. So if it moves in the United States military, it starts with and is moved by United States Transportation Command.
Every one of the Air Force's C-17s that flew resupply missions for Operation Enduring Freedom and Operation Iraqi Freedom was sent by U.S. Transcom. Every one of the Navy's roughly 100 LCACs running supplies from ship to shore is coordinated by U.S. Transcom. In fact, every military supply truck, cargo ship, and airplane full of equipment is overseen by U.S. Transcom. During the first year of Operation Enduring Freedom, U.S. Transcom shipped more than 420,000 tons of supplies to aid more than 50,000 soldiers, coordinating thousands of cargo missions from bases in Europe and the United States.
We're a combination of not only the Air Force, the Army, the Marines, and the Navy, but the Coast Guard, our commercial contractors, and many of our civilian employees. It takes that whole team to be able to make Transcom operate.
Bringing such diverse services and industries together has streamlined logistics for today's modern military. But the concept of centralized military transportation has been around for a while. Each branch, for example, has attempted internal coordination.
The main lesson with each war, from the Revolutionary War up to World War I, is that transportation has to be centralized under one authority. And so it's in World War I that the American Army, both in France and the United States, creates a singular office to control this, called the Chief of Transportation.
But offices with limited power within one branch of the service were inadequate to effectively coordinate a multi-pronged force like the American military. Planners needed something bigger, answerable only to the Department of Defense.
Before Transcom, the services did their own transportation, and they did it very poorly. The services are very reluctant to give up any of their transportation assets. So there has at least a dozen major attempts since the Second World War to unify transportation in the Department of Defense in some way. They all failed for parochial service reasons.
Then in 1978, the United States lost World War III. At least that's what happened in a top-secret computer war game exercise called Nifty Nugget. With an enemy invading Europe, the Department of Defense simply could not reinforce its troops. Shocked military leaders were forced to confront the need for a central logistics command. By 1987, all the pieces had fallen into place. Now Army, Navy, and Air Force component leaders would work directly for the Secretary of Defense, reducing bureaucracy. When the Gulf War began in 1990, U.S. Transcom used the conflict to prove its efficiency, flex its muscles, and work out some bugs.
It validated everything we said we needed for a new airlift aircraft. And also it showed that we needed to greatly improve our readiness and capacity of our sea-lift force, which had gone into tremendous neglect.
Sea-lift was improved. Loading and unloading was modernized. New aircraft were ordered. U.S. Transcom took on the characteristics of an efficient company. It even refers to its clients as customers. Not surprisingly, it also relies heavily on IT, or information technology.
We are very IT intensive in U.S. Transportation Command. We have multiple systems that are used to track planning, capacity, and execution. So at any given time, we not only know what capability we have available, what capabilities are being used, where it is in the world, not only the lift platforms, but actually all the